Hey everyone, let's take a look at number 1 in section 6.2. We're to find the volume of the solid with the given base and cross section. So the base is going to be a circle. The circle x squared plus y squared equals 25. You should recognize this is equation of a circle with radius, right? R squared is 25, right? So the radius is 5. Of course, the center would be at the origin. The cross sections for our solid are going to be that are perpendicular to the x-axis are going to be triangles whose height and base are equal. So to set this up, I'm going to think of this circular base here. I'm going to put it in the xy plane. So this object is coming out of the paper towards us. And the cross sections perpendicular to the x-axis. So here's the x-axis. So if of course, I'm going to be talking about from x equal -5 to 5. I'm going to vary x. If I bring x out to an arbitrary location, say right here, and slice downward right through our object, what will this slice look like here? Well, if I pull this slice out and flip it up and take a look at it, look at it from this way, what I'm going to see is a triangle. Here will be the base. This part right here, the bottom of the triangle is this, right? And notice as x varies, that base will widen and our triangles will get taller, of course, because their height and base are equal, the same length. So the way I set this up is this distance is x, right? And obviously, because these are perpendicular to the x-axis, I'm going to call just the height from above the x-axis here to be y. Okay. And then notice because the circle is a circle of radius 5, if I go from the origin to the circle here where this point uh, to this point right here, right, this is 5. And you can see we have a right triangle here. And from that, of course, we get the equation that we already know from our circle. But we know that x squared plus y squared is 25. And so what is y equal to? Well, if I can solve for y by subtracting x squared and then taking the square root, which will be true for any value uh, of y in the top half of our circle, right, where y is positive. Negative root would be the bottom half of the circle. But I'm going to let that be the length y. And then notice I've got the uh, base of my triangle is 2y because if this is y by symmetry, this length is also y. So the total length here is 2y, which means the height is also 2y because our triangles have height and base equal. The base and the height are the same. And so what's the area of this triangle? It's 1/2 the base times the height, which if I multiply that out gives me 2y squared. Well, I know that y squared is equal to 25 minus x squared. And so if I replace that for y, I get my cross-sectional area here, right, of this triangle, slide it back in, that triangle. As x varies from -5 to 5, that cross-sectional area is 2 times, of course, y squared is 25 minus x squared. So here's our cross-sectional area. So this is very important that we're able to express this. And notice this works because as our triangle, notice our triangle right when x is 0, we'll have our biggest triangle, and clearly the base will be what? Since this is a circle of radius 5, the diameter will be 10, right? So the base will be 10 and the height will be 10. And so the area would be 1/2 10 times 10, 1/2 of 100 should be 50 square units. So let's see if that's the case. When x is 0, right, what do I get from my formula? Well, if x is 0, I get 2 times 25, which is 50, which is exactly what we said the area would be. And notice the area gets smaller as x gets closer to 5 or -5. In fact, by the time we're equal to 5 or -5, the area becomes 0. And that's true if you plug -5 or 5 into our area function, we will get 0. Okay, so how do we find the volume of this solid? Remember, we integrate this cross-sectional area from, in this case, from x equal -5 to 5. So in doing that, 2 is a constant multiple pulled out. Antiderivative of 25 minus x squared is 25x minus 1/3 x cubed. I plug in and evaluate this at 5, and at -5, I pulled the 2 out here. And if I do that calculation in here, I get 500 thirds. times 2 is 1,000 thirds. And they did want the answer to be exact in fraction form, so this would be the answer that we have. So the volume of our solid is 1,000 thirds, or 333 and a third cubic units for the volume. Okay, hope this is helpful.